Hello everyone, in this video we will learn about logarithm rules. So let's start with rule number 1, which is the product rule. So if we have log to base a of xy, so here the base is a and the argument is xy, we get log to base a of x plus log to base a of y. So if the base is a, the base will stay the same, and here we must add the logs. So let's look at example 1. So let's express these logs as a single log. So here we have log to base 7 of 4 plus log to base 7 of 3. As we can see, the base is 7, so the base will stay the same. So here we have log to base 7, and then we need to multiply the arguments. So here we have 4 times 3, and if we calculate this, we have log to base 7, and 4 times 3 is equal to 12. So now let's use our calculator and find the answer. So here we put log 12 over log 7, and we get 1.2769. So let's round this answer to 2 decimal places, and we get 1.28. So this is 2 decimal places. So let's look at the next rule, which is the quotient rule. So if we have log to base a of x over y, so here the base is a, again the base will stay the same, and in division we subtract the logs. So here we have log to base a of the numerator, which is x, minus log to base a of the denominator, which is y. So let's look at example. Let's express these logs as a single log. So here we have log to base 5 of 4 minus log to base 5 of 3. Okay, so here we have log to base 5. The base will stay the same. And here we have 4 over 3. And now if we want to evaluate this answer to 2 decimal places, okay, so we just put log of the argument, which is 4 over 3, over log 5, and we get 0.1787. so let's round this answer to 2 decimal places, and we get 0.18. Okay, so let's look at now example number 3. Log to base 9 of 4 plus log to base 9 of 3 minus log to base 9 of 6. So this equals to log to base 9. Okay, so in addition, we multiply the arguments. So we have 4 times 3 over, because here we have subtraction, so we must divide, over 6. And the answer is log to base 9. 4 times 3 is 12. 12 over 6 is equal to 2. So this equals to log 2 over log 9. And the answer is 0.31546 dot dot dot. So this equals to 0.32. Correct 2 decimal places. Rule number 3 is the power rule. So as we can see here, we have a power n, so we can just move this n down. So log to base a of x to the power n equals n times log to base a of x. So let's look at this example. As we can see here, we have 2 log to base 7 of 3. So we can move this 2 here. So this equals to log to base 7 of 3 squared. So just move the 2 here, becomes the power of 3, plus log to base 7 of 5. Okay, so this equals to log to base 7, 3 squared is equal to 9, plus log to base 7 of 5. Alright, so now we are back to the first rule. Here we have addition, as we can see. So this equals to log. As we can see here, the base is the same. So here we have the base 7. So the base will stay the same. So in this case, we have log to base 7. and just multiply the arguments. 9 times 5. So the answer here is log 2 base 7. 9 times 5 is equal to 45. And we can now just use the calculator to find the answer. So log 45 over log 7 equals 1.96. Correct to 2 decimal places. So I will explain how to find this answer at the end of this video. Rule number 4 is the zero rule. So if we have log to base a, so log to base of any number of 1, so if the argument is 1, the answer is always equal to 0. So let's look at this example. As we can see here, the middle term is log to base 9 of 1. So straight away, this equals to 0. Straight away. So now we have log to base 9 of 8 minus a half log to base 9 of 4. So this half can be moved here. It becomes the power of 4. So minus log to base 9 of 4 to the power of a half. And 4 to the power of a half is the same as square root of 4. So we get 2. So here we have log to base 9 of 8 minus log to base 9 of 2, because 4 to the power of a half is equal to 2, is the same as square root of 4. And finally, now we have subtraction, and the base, as we can see, is the same, 9 and 9. So now we can express these logs as a single logarithm. So this equals to log to base 9, and remember, in subtraction we divide. So we have 8 over 2, and this equals to log to base 9 of 4. Alright, so let's look at the next rule, which is number raised to log. So here we have a to the power of log to base a of k. So as we can see here, this number and the base are the same. So just imagine you are cancelling them out and we just get k. So let's look at this example. We have 9 to the power of log to base 9 of 5. So just imagine you are cancelling out this 9 with this 9, and simply the answer is equal to 5. Alright, so now let's look at the next rule. So if the base and the argument are equal, then the answer is equal to 1. So if we have log to base a of a, we get 1. So let's look at this example. Log to base 5 of 5 is also equal to 1. Rule number 6 is called the change of base theorem. So if we have log to base a of x, we get log to base b of x over log to base b of a. So you can choose any base. So here the base is b. It can be any value. So you can use 5, 5, 6, 6. 10, 10. So if I look at my calculator, I only have the log button and the ln button. So in this case, log to base a of x is equal to log x over log a. So the argument goes at the top and the base goes down. So this is also equal to ln x. So you can use the ln button, that's also fine, over ln a. So let's look at example 6. Log to base 5 of 6 is equal to, so as I told you, I only have the log button or the ln button. You can use either one of them. So this equals to log 6, the argument goes at the top, over log 5, and the log button on our calculator has a base of 10. So in this case, our base is equal to 10. So let's use our calculator and find the answer. So log 6 over log 5. Even though you can't see the base on the calculator, but the base is actually 10. So here we get 1.11328 dot dot dot. So let's round this answer to 2 decimal places and we get 1.11. So you can also use the ln button. So if you put ln6 over ln5, we also get the same answer, 1.11. Thank you for listening.